this morning we had a couple of questions about edge compute, right? So where is the edge? Where does it go? Right? What sort of buildings? We had more discussions about that at lunchtime. So people are asking, well, is every cell site an edge compute? Are all the macro cells an edge compute? What goes where? And then we also had a lot of questions this morning about fiber. So do we need more fiber for 5G? Is it fiber everywhere or just bits and pieces as we need them? So we planned this. We actually planned this panel as well, unlike the last one. Randy and Jim are going to talk respectively on edge and fiber. Okay, I'll let them introduce themselves in a second here, but we actually did prepare some questions which remarkably match up really well with the questions we had this morning. So good news. So we're going to talk about edge and fiber, simple as that. So Jim, if you want to introduce yourself first, so I know many people know you, but who you are, what you do, why you're here, and why you care about fiber and edge, and fiber and 5G.
Wow.
Yeah.
So for those that don't know me, my name is Jim Stegeman. I am president of CostQuest. CostQuest is an economic modeling firm. We focus on the cost of network deployments. And a lot of our work is used by many of the parties in this room to develop what it would cost new to deploy fiber networks, cellular networks, core networks, all those types of networks. But we've also done work for the federal government, state agencies, and we're probably best known, if that's, best known as, in my view, for our work with the FCC. So we developed the cost of fiber deployment to every home and business in the country. And that model is used by the FCC, one, to develop their national broadband plan, and two, to disperse $4 billion annually for broadband deployment in the country. So
the FCC is not working right now. Half the government shut down. So you're on vacation?
I wish.
Okay.
I wish.
All right. So Randy, I'll let you introduce him. Same thing. Randy and I have known each other for a while. I can tell you he likes a few beers. But we met through edge computing conferences and stuff. So I'll let Randy introduce himself, what you do, etc.
Well, most importantly, I live here in Austin, Texas. So yeah. I work for Affirmed. Anybody from AT&T in here? I saw some people. Yeah. Okay. Good. Yeah. So AT&T is one of the largest software virtual networks in the core of their mobile network, and it's based on Affirmed software. So I work closely with service providers developing their mobile core network, and obviously what Iain was talking about, a lot of the activity today is once you have a software element, you can move that software element closer to the edge of the network to improve the performance, reduce the latency of networks. You also improve costs. You do all kinds of things. So I've been with Affirmed for just over a year, and prior to that, working for another company that was developing the solutions for the edge of mobile networks. So I have a pretty long experience in kind of mobile edge networking.
Kind of edgy. All right.
Very edgy.
Okay, so let's get to the first question. So first question is current status, and Jim, I'll let you go first. So are we still building fiber? Is it still going in the ground? One of the questions this morning is, do we have enough already, or are we going to keep building?
Clearly, there's not enough. There is a massive amount of fiber being deployed. AT&T is just wrapping up a kind of a GPON deployment in major cities. Verizon finished up their Fios network years ago, but many of the carriers are still deploying network or fiber in their networks. One, to compete against the cable companies, and the cable companies in turn are deploying more fiber to compete against the fiber being deployed by the telephone companies. You also have government institutions funding the deployment of fiber. So New York State had a $500 million fund to expand fiber deployment within the state. And they had a reverse auction to do that. So it went fairly well. And there's a number of other states that are looking to mimic that deployment. So it's, in some aspects, it's cities trying to take control cities and states taking control of how fiber is deployed. And then you have municipal networks being deployed. There's going to be a big announcement coming up soon, a big announcement of about 1 million lines from a new entrant who will run fiber past 1 million homes. So that will be coming soon. And then the last part is the FCC just auctioned off, I got to remember my number, $1.5 billion. And that was for fiber deployment or broadband deployment in rural America. And much of that money went to actually fiber deployment by rural electric co-ops. They're the new big thing in the industry of they've got to deploy fiber for their smart metering, for the control of their network, and as they're doing that, they can cheaply deploy fiber to their customers.
So those rural deployments, then, is that going to be fiber around a small town, or is it going out to, let's say, cover a farm or rural highways? Is it where the people already live, just giving them more fiber?
It's actually, a lot of it's focused on counties, so it may be entire counties, but it's typically the more urban, not urban, the more populated rural counties.
Okay.
But it's still an issue out in the farm areas.
Right. Good. Okay. So Randy, same question. Edge compute's been talked about for a while. Mm-hmm. So are we building it? Are we still talking about it? We're trialing it? Where are we at?
Yeah, we're building it. So the service providers are now starting to. They've done most of the cost models and started to figure out how they would integrate edge technology into their networks, and a lot of the mobile service providers are now moving out towards the edge. Different ways, different technologies, but it's happening. I think the main thing now is the service provider working with the enterprises to figure out exactly which applications they need or want. In the consumer market, I think there's a pretty good consensus of 3 or 4 main applications, and I think you'll start to see those applications, AR, VR, gaming, video, those types of things, are all have good use cases for edge, and now we're kind of looking towards the enterprise for which applications they need.
You weren't here this morning, were you?
I wasn't.
See, those applications you just listed? That's the drunken duck, right? I had this slide with a drunken duck on it because the AR, VR, that lag between the brain and the eye, right?
Latency issue, yeah.
Latency,
yeah.
See?
That's right.
Yeah. Looks like we planned this. Didn't. Okay, good. So, all right. So let's talk about 5G specifically, since we got into 5G. So, Randy, I'll start with you. Does 5G need edge, or is edge nice to have? Right? Can I build a 5G network and say I'm not doing anything with the edge at all?
Yeah, I 5G to me has 2 or 3 things in it, right? There's going to be higher speeds in it, so you can build 5G and have use some of the existing applications and just have higher speeds on them. 5G has a lot of radio access development, so you can be more strategic in how you place your assets. You don't have to spread them out as much potentially. But another thing about 5G is you really get into some of the technology, but kind of the cloudification of the mobile network architecture. Take it from what has been a legacy IT deployment for how you build the core of the network and turn it more into what like a data center at Google and Amazon look like, where you're in containers and you're operating the network much faster, more efficiently, reducing the cost of operations. That's in 5G also. And to make it really complicated, you take a lot of the elements and you change the names of all of them, and then you one of them is to move out towards the edge. So it is an important element of 5G, but can you do 5G and never worry about the edge? Sure.
So edge compute for you then in an operator is not just to keep all the teenagers happy with AR, VR, Fortnite gaming, right?
Right.
But it's actually the operator saying, here's all the core network elements I used to do in that data center or that central office over there. I'm taking that, virtualizing it, and now distributing it.
And reduce the cost to the service provider to deliver those services and improve the efficiency of being able to respond to a customer that says, I want you to change it and do these things to it. instead of that being a real stovepipe approach, it's very, very flat oriented, and you can do those things in operations.
Right. So these guys are all, tax valuation,
Yep.
property guys. So all that equipment I have sitting over in my centralized data center,
Write them off.
you're
Write 'em off.
you're ripping that out, virtualizing it and spreading it all over the place.
It is evolving, that's for sure. Yeah. The difference being that there's been specialized technologies for those in the past, and general compute technologies are now applicable for a lot of that infrastructure. So you don't have to have specific custom built pieces of hardware. You can go, Dell and HP will be really happy to be able to roll those things out.
Yeah, which changes the cost structure and the
Cost
valuation
structure,
and all
yep.
that.
Yep.
Right. Okay, good.
And the people that you have to operate them too are different people potentially, or have different skill sets.
Different skill set. Yeah.
Yeah.
Good. All right. So Jim, fiber and 5G. You just listed off a whole bunch of builds here that are happening with fiber, and money that's going in there. Are the justifications for that 5G? Were they saying, well, these counties or New York State saying, hey, we need to get ahead of 5G, so we're going to build fiber? Or are they just saying, let's put fiber in and see what happens?
Actually, like some of the states in the federal programs are actually not even thinking about 5G.
Okay.
When I worked on the New York project, which actually was 2 years ago, the focus was on residential and business locations. They had no thought of 5G. I tried to bring it up that they had to think about the potential for that, but it was not part of the policy and part of the guidance of what they wanted to do. So no, some of the states are not. But as you build out in these rural areas, then that fiber becomes available for the 5G backhaul. That is needed. It's a big issue because if you look at LTE sites today, average backhaul bandwidth is about I want to say a gig. In a couple of years, it'll triple to maybe about 3 gigs, and with 5G at the home site, it will push 10 gig. And as you think about that, there's not a lot of other technologies that can be used to handle that type of backhaul. So you really have to have that fiber out in the network, whether it's to each and every 5G site. Likely not. We heard from the AT&T technology expert that maybe we can use radio backhaul. It's still in the labs, but I think you're still going to have a lot of fiber out there because you can only have so many hops. And if these cell sites are 200, 300 meters apart, you need a lot of fiber sitting out there.
Right. So to get from that 1 gig to 10 gig, do you put in more fiber strands to a tower, or can you do it with the same fiber and just upgrade the equipment?
Typically, you can upgrade the equipment.
Okay.
You can. Many cell sites will have a Metro E termination. So the providers, whether it's Comcast or AT&T or whoever it is, will provide a Metro E link. That Metro E link can go from 10 meg up to 10 gigabit as a Metro E link. And then you can do wave division multiplexing at that site to actually increase the amount of traffic over that single strand.
Right. So the 5G impact on, I'm going to paraphrase here and you can agree or not, the 5G impact on fiber is fiber to more places, not necessarily just a higher strand count to the same places we've got fiber going today.
I would agree with that. It will be fiber to more places. There will be a higher strand count on the route, but the same strand count to the place that it's going to today.
Yeah. Okay.
Yeah.
So just more fiber, more places.
Yeah.
So, all right. Good. Okay. So let's talk about equipment and like what goes where here. And let's start with that, with the fiber stuff. So you just said, we said glibly change out the equipment. Right. You said, the cable guys, they've got that equipment there, we just change it out. So what's actually involved here in either A, lighting up a dark fiber, or B, increasing the capacity of that fiber that's there? Yeah. What are we actually doing here?
So what we're doing is typically the wireless provider, they're starting to deploy some of their own fiber, but many times they're going to buy it from someone else. Crown Castle is a big fiber provider to the towers. CenturyLink provides fiber out to the towers. That fiber is put out there, and it can either be a dark route going out there, and They request a service, and that service is a Metro E, and they'll deploy a piece of electronics out at the cell site, which is a Metro E terminal, and then having something back at a hub location to terminate that service. They can do wave division multiplexing out there so that they can actually aggregate multiple beams of light onto that single fiber going back. But again, it's an equipment deployment, so they have to go out. If the bandwidth increases, they do have to make a truck roll to put in a new piece of equipment out there. Typically, if it's a Metro E site, they'll have to switch out a card or put in actually a new device.
So you are sending somebody out to the site, and there's actually physical hardware involved.
Yes.
Yeah. So,
Yes.
All right. Good. All right, Randy. So all this edge stuff's getting out there. You said we're just moving things around and just Dell and HP servers dropping out the sky. Where are you putting them? What does it look like? You and I at the break had a discussion about cell sites. But what do these actual edge compute locations actually look like physically?
Yeah, this is one of the most exciting things I think for in the mobile space is this is a new place for them. They have not had this equipment there, so you're not ripping and replacing anything. It's a greenfield in most cases, and the objective with the edge is typically mostly to reduce latency, to offer applications and services. Dr. Heath was talking about the cool things you can do with drones, but if you can't control it with a mobile device, then the drone is really a line of sight type of application. If you can reduce the latency by putting elements out towards the edge so that you can reduce the latency between the communication I have with that drone, then you can start to operate those types of applications. And there's lots of them. Cars communicating with each other is another example. But you have to move up at least a critical piece of software out into the infrastructure closer to where the signal is originating. And so where do those go? They can go a lot of different places. They can go on towers. They can go at existing mobile service provider central offices or data centers that they have in the field. They can go at enterprise locations. They can go at a number of different locations. Today, the signal from the fiber, the cell site and the fiber carries the traffic up a pretty long distance, and that adds latency to the solution. So to reduce that latency, you have to move that infrastructure out closer to where it can be processed quickly so that it can respond to the requirements. Not every application, and probably the applications you use today, don't care about latency because those applications haven't been introduced in a lot of cases because the latency causes problems with them. So where will they go? It's a complete greenfield, and service providers have that opportunity to look at where they need new equipment. It might be at enterprise location, it might be at your offices, it might be at an existing mobile service provider location. But it can be anywhere from a hardened compute platform to a regular Dell compute platform that's at a data center that's operating like any other.
So it literally can be a small rack with a couple of blades in it.
Sure, a 1U platform could be enough capacity to do what it needs to do.
Right.
Because all you're going to do is you're going to take what's in the core of a mobile service provider today, software elements. You're going to disaggregate those elements and just take the ones you need to the edge, and leave a lot of the control plane types of things in the core of the network. You don't care about latency on control plane for the most part. You'll just care about the user plane.
Right. So what's the smallest edge deployment you've been involved in is that 1U rack?
Yeah, that's still a challenge, is exactly what that is. But yeah, 1U is typically, and then you start getting into what's the smallest based on how many cores does that 1U have.
Right.
And so that, as you can continue to reduce that, you continue to reduce the cost of that.
Yeah.
And
what's the biggest edge deployment you've seen?
Yeah, I'd say they're typically based off of compute platforms, and you get compute platforms in 1U with 20 cores roughly in them. You can get them down to 8 cores, CPUs inside of them. So, but gosh, there've been ARM Raspberry Pi
Yeah.
edge solutions as well. So those are really small.
So the one you're talking about, I think, is on the truck, right? Is that the example?
Yeah, exactly.
Yeah.
The Raspberry
So,
Pis, yeah.
There's an example of an 18-wheeler refrigerated, right? And there's all the sensors in it for the refrigeration and stuff,
Yeah.
and they connect to Amazon Cloud. So you got all this data going up to the cloud saying, yeah, I'm cold. Yeah, it's cold. Yeah, it's cold. Still cold. You can aggregate all that on a small Raspberry Pi processor on the truck. It aggregates everything, logs it all, but when there's an alarm, it decides, do I need to tell the cloud about it, and sends it up. And the business justification for that application is the traffic up to the cloud, the savings of actually sending all those transactions up. It pays for it.
That's
Very
right. If you look at Amazon, the way Amazon would charge that enterprise would be the number of messages they send and how big those messages are.
Yeah.
And so if you take that and put it on a truck itself, then you eliminate the message charges and the size of them. You aggregate them and just send what you have to send.
Right. So final question on this, because this is good. Is there a standard type edge deployment? I mean,
There are standards, and they're evolving. The vendors are still, demonstrating their examples of some of these things. But I think we'll be okay with standards. There's two general kind of industry standards around Etsy with a MEC standard that's mostly being developed right now, and then 3GPP with the release 15 and 16 standards around
Right.
Control and user plane separation.
yeah. Good. Okay. I've got a few more questions. But any questions? Yes.
Because you have long stretches before you get to, maybe me, I'm the farmer, can I use the conductor versus fiber for something, and then maybe just use something that's an application at the end in order to have that household that's on a farm have internet availability? What's the way that the co-ops are looking to deploy with the money that they are going to get?
So most of the co-ops I know are actually doing a full fiber deployment to actually every location in their footprint. They're using that money along with the co-op, the owner's money, which are the individual customers, to actually help fund that. And the money they're getting from the FCC, one through the auction, they're actually going to run fiber out to every farm, every home in their footprint. I know in Missouri, it's probably the biggest area where the rural electric co-ops have entered. There's a consortium of rural electric co-ops that won in Missouri. Actually are going to deploy in a lot of the AT&T footprint, and they will have full fiber service in that footprint.
Now, what about the AT&T?
They're actually going to roll out into the AT&T footprint, so they will overlay the AT&T footprint in that area.
Okay.
Yep.
As of this morning, Amazon has started offering a fairly interesting service where they will terminate TLS connections between a browser and a back-end server at their load balancers within their data centers. And it's completely transparent to everything, so that's actually kind of interesting. What I'm asking about here is, that's easy for Amazon to do, and we see this where people own entire data centers. They can do things like that. There's no technical reason why you can't, but is anybody actually setting up to build and offer business services using NFV or whatever to be able to run third-party applications on these edge servers?
Sure. Yeah. Well, like Amazon's a good example, actually. In the edge, they already have a solution that they really designed for enterprises that we were talking about before, to be able to allow for small clouds to be placed at the edge of the network that communicate back with big clouds like Amazon data centers. And so they've already written that solution, and they sell it to enterprises. Microsoft has done the same with Azure. Google has done the same. So they're ready for micro locations. The best micro locations relative to mobile are in the mobile service provider. So as soon as they can release an edge type of solution, then that'll start to birth these micro data centers. Enterprises are taking advantage of them right now, since there aren't mobile networks like that available to them. enterprises just use those kind of micro data centers at the enterprise that link back to the Amazons and Googles of the world.
So right now, if you are a web developer, right, 5 guys in a garage, and you develop your app, you go onto Amazon Web Services, you fill out a form, or the other public cloud guys, and you fill out the form, says I need this many machines and this much resources, right, and load up your app and off you go, right, and they send you a bill. Simple as that. And you don't care which data center you're running in, where it is, Amazon takes care of that, right? Which is the beauty of the whole thing. So in the olden days, your developers would be calling up Dell and HP and saying, hey, send me some servers, and building a little data center for themselves. So we've got way past that. So the next step is to take that as you're the developer sitting in the garage, you develop your app and you say, well, this bit's going to sit in the cloud, but this piece of my app is going to sit at the edge. And the edge to me is here. It's Austin is the edge, right? Could be the hotel is the edge. Could be this room is the edge, right? The edge is going to move depending on who you are. But the next step is to go into that web services and say, I want this many resources here in the cloud, and then I want this many resources, right? To Randy's example, I want equivalent of 1 U box at the edge. And the edge is here to me, right? Check. Make it happen. Here's my app. Send me a bill, right? That is about 3 weeks away from being announced, because an announcement came at the end of February at Mobile World Congress between one of the big public cloud providers and Ericsson has a company called Gravity Edge that's worked with some operators to do this, to link out to the operator. Because the trick is you've got to get Amazon and company working with AT&T, Verizon, Singtel, China Mobile, et cetera, and connecting to their networks. Some of the operators say they're going to work with the public cloud vendors publicly together. Others are saying they're going to build it themselves. You and I were talking, so AT&T is a good example of that. So yeah, that's exactly where it's going to get to. We get to another layer of abstraction, another layer of complexity, and we'll be talking about that fairly quickly. So it's going to take a while before you go, hey, I need to check the Hilton on 4th Street, right? But saying, yeah, push this to the edge in Dallas, Houston, Austin, that's probably months away. So. And
I think the fiber in the rural scenario is an interesting situation too, because in that rural example, you can build the fiber networks to physical locations, but in a farm, for instance, you have assets that move around that might be combines, and you might have items that need to move. And so what you've done is you've required the farmer himself to either build his own mobile network for those assets, or he needs the service provider to provide a mobile network for those types of things. So getting fiber to it is great because they now have high-speed access at a fixed location, but now you need to consider the mobile assets that need to move around, that you'll have to build a network for those items. So just getting fiber to those locations solves a problem, but maybe doesn't solve all the problems, because you have really wide area farms that have combines that need to run more efficiently and such. And those assets are going to need connectivity. Unless you have mobile network infrastructure there, you don't have those that capability.
Back in Texas, those combine carried with satellite signal.
Yes, so if you can withstand the latency of that, I mean, we've done some examples with Caterpillar where those signals, the combine didn't turn in time. It ran completely off of the location that it was doing. So you really need some low latency for some of those applications, because you're making decisions and you're planting or you're mowing or you're doing something that the combine needs control. If you don't have the low latency capability, then the application doesn't exist there.
Yeah, in regard to that combine, just had to jump in here. The FCC is going to actually hold an auction this year, a $5 billion auction for mobility, in which they are going to auction off every bit of uncovered meter in the U.S. So all the providers had to provide their coverage maps to the FCC. From those coverage maps where 4G was not available, that part of the country will go up for auction And it'll be a $5 billion fund for providers to build out new infrastructure to those areas to provide service to that combine. So potentially 5G will be available out there.
Yeah. So your example of the counties and those co-ops as well, building fiber to every large farm, every homestead, you can have a farm, the farmer orders Microsoft Azure Stack, box arrives, he plugs it into the fiber, he's now got fiber, he's got edge compute, he's got a lot of computing power. He then goes and orders some CBRS radios off the web, 3.5 gigahertz, unlicensed, deploys them around his farm. Now he's got a wireless network, his own wireless network across his entire farm with edge compute sitting there. John Deere will happily give him some applications to run on that for the combine control, et cetera, et cetera, et cetera. It's a little data center right at the edge, and literally not that you could do. Actually, you could do that today if you had the fiber connection.
Right.
Yeah. And you would order the Microsoft Azure Stack off of Amazon, but that's a joke.
What you're saying is that this is a democratized approach to the servers, or are these serverless applications? Or, I mean, what you just described is basically a serverless application, but you were talking about it as being servers. So
yeah, so the Microsoft Azure Stack are the servers, right? But there's nothing to stop a farmer owning his own. Enterprises have them today.
So it is a democratized
Yeah.
approach to
Yeah.
distributing edge. Okay.
Yeah.
The other question: what is the physics that is limiting or increasing the latency? So light can travel halfway around the world in 66 milliseconds, right? So what is it? Is it the electronics that are slowing down that?
Yeah. So,
I can start. So if you look at the full end-to-end latency of a mobile network architecture, for instance, you have latency at multiple steps and different places. So 5G, first of all, has an objective to reduce the latency in the RAN portion of it, but then you have a distance and an equipment issue in that you have maybe 10, 12 mobile cores throughout. So you're traveling a pretty good distance through electronics. There you're adding latency all along the way. Where with if you've got the access at the RAN, if you can put the compute capability near that location, then the only latency you're really experiencing from a user plane perspective is the air interface latency instead of the distance and the additional electronic hops.
So it sounds like it's mostly electronics. Distance is one, but I mean, if halfway around the world is 66 milliseconds. Electronics is really the choke point for much of it, right?
The round trip on a LTE network, if you do a ping test on your phone, you'll see 60, 70, 80 milliseconds. So 60 to 70 is what we typically say we can do. If you take that application and move it to the base station, you'll get that down to 30 milliseconds straight away, just by removing all those hops that Randy is talking about. The speed of light in fiber is not the speed of light. It actually slows in fiber. And I think it's like 60% or roughly is the number I always used. And the other problem is that the fiber doesn't go straight. So here to Dallas, this hotel to Dallas, you actually may go here, Austin, Round Rock, Houston, Dallas, right? It could be a 500-mile trip to go a couple of hundred miles, which doesn't sound much, but when you're talking about robotics and things, a couple of milliseconds. You said around the world in 66 milliseconds. Halfway around the world, right. But industrial applications, they're talking about the 5G, they want 1 millisecond latency. And you can do that with optimized RAN, like I mentioned this morning. So the radio right now doesn't know what traffic you've got going across it, and it doesn't really care, right? So Jim's Facebook is the same as my heart surgery, right? So the radio would actually prioritize that, slow down his Facebook, speed up my heart surgery. But I always joke, Stephen Hawking is now dead, right? So we can't change the rules of physics anymore, right? We're stuck with what we put. It is a physical limitation that we have.
Unless you go to a quantum state.
Yeah, then we're into science fiction stuff. The other thing I was going to say is Randy was saying about the edge compute, the number of cores, right? Our forecast, when we do forecast how much spending there will be at the edge, It's not that much money, actually, in the big scheme of things, because servers from Dell and HP and company are cheap, right? But the thing that limits it as well is in our forecast, we actually have the assumed number of cores on average per year that you can buy. So as Intel starts packing more cores into the chips, it reduces the need to buy more and more servers, right? The power in a server today compared to what you had, 5 years ago is just incredible. It's incredible. So edge compute doesn't mean that, half the room is going to be filled with racks and racks of stuff. No, it could be one little box sitting in a corner. Wouldn't be that big. So we about done?
We're about done. I had a couple questions, one for Jim
Okay.
and one for Randy.
Okay.
Going back to the rural deployment where you have a fiber out to the farm, and then a little network to go with that, the economics of that require subsidization in general, or from the government? Are there cases where?
Yeah, I'll have a map in my presentation tomorrow just to show you the economics, but typically the economics, when the linear density, which is the number of locations per road mile, gets under 15, starts to fall apart quickly. Yeah, it's all rural America, basically. Yeah, and when I show you the map, it's basically the whole country. So the only way you can do it is through subsidization of some type. And actually, the speaker tomorrow, Commissioner Mignon Clyburn, one of her critical issues is you don't only look at it from the aspect of the cost to the provider. There is the cost, the societal cost. How much additional health care can you provide over that broadband link that actually reduces cost in general in the society? So how do you factor that into the decision as well as what she'll talk about?
Good, thank you. And my question for Randy is, so with this edge processing, you're kind of distributing processing power into more places closer to the customer, if you will. Does that mean that people that are worried to track assets for, say, communication carriers are going to have more computers at the cell sites, for example, and less computing somewhere else, or is it just?
Yes, I think that's the way that I've seen most service providers have been looking at it. Hadn't been an incremental. It's been kind of reducing some of the core assets because you've moved assets to the edge. Overall, the math works out that we see, the need for bandwidth and the need for data capacity just increasing, and so it's not we've come to the max level now, and that now we can build for it. It continues to go up. It's just where you're putting it that we're addressing.
Okay, thank you.
I got two more questions. One
Okay.
more question.
We've got a couple minutes.
Last question, Jim, you go first. What keeps you awake at night? What's the most terrifying thing about fiber that we're going to worry about in a few years and go, darn it, should have done that?
What probably keeps me awake is just the lack of fiber. Lack of fiber.
Will we ever have enough fiber?
There's not enough fiber. I mean, it should be, and maybe I sound a little over the top, but you really need fiber to everyone,
Okay.
or fiber everywhere, because without it, we can't advance with the bandwidth requirements that are growing, with the edge computing that needs to be happening. You need fiber everywhere.
So it's like that fridge magnet. You can never be too rich, too thin, or too good looking or something.
It's something like that,
Yeah.
yeah.
Randy, what keeps you awake at night with regard to edge, not all other
I'll just
stuff?
stick to edge.
Yeah, yeah,
Oh,
yeah.
okay. I was gonna say Aggie football recruiting, but I'll go to something else. So.
Hey, you're like third in the nation now. What are you worried about?
That keeps me up. I'm looking for number 2, not looking for number 1. So,
Hey, if Clemson can do that to Alabama, A&M could do it in a couple of years.
of course, yeah, absolutely.
Impressed, I know this.
And being an Aggie in Austin, Texas, I often refer myself as a missionary here.
Well, you live in
town,
Round Rock, so don't worry about that.
Well, it's Austin, and so here to save the lost Longhorns. So.
What's the question? Yeah.
What? Yeah. What was it again? Yeah. I think just the how fast we really have to move. The requirements in mobile networking are exceedingly high. The expectations are high, and deploying networks is a pretty intensive process with a lot of people involved. So. Just coordinating all the activities that are necessary to meet those expectations.
Great. Thanks, guys.
Thank you.
Very good. Thank you.